Okay, before we get started, my daughter wants to say something.
It's fun drawing math.
Okay. Okay, so we're going to go over the paper part of this homework because a lot of you didn't seem to be able to get it. So we were asked to find the area between these two curves two different ways. So we're expecting that we get the same answer since it's obviously the same area, just two different ways. So first I'm going to do this with respect to y. I'm not sure if that was part A or part B. In terms of y, we need to know what these intersections are. This looks like it's probably a 2, and this looks like it's probably a -3, but let's just go through it. So we're going to set 4 minus y squared equal to y minus 2. This is quadratic, so the best approach for solving quadratics is to set everything equal to 0 so that we can factor it. So I add the y squared over. I'm going to subtract 4 over. So I had this y over here. So add 4 over, and that gives me plus 2. And so we factor, something's wrong, let's see, so 4 minus y squared, y minus 2, bring the y squared over plus y, when I subtract the 4, sorry, okay, subtract 4, not add, sorry, so this is going to be a negative, let's erase, it's going to be a -6, sorry, okay, so now we've got plus 3 and minus 2. So zero product property says I have the product of two factors, the result is 0, so it must be that either the first factor is 0 or the second factor is 0. So subtracting 3 we get y equals -3, and over here adding 2 we get y equals 2. So that tells me that this point down here is something comma -3, and this point right here is something comma 2, where those are my y values. While I'm doing this, let's go ahead and find the other something. So when y is 2, we get x is 0. Notice that that's true up here too, right? 4 minus 2 squared is also 0. So either equation we get 0, and then when y is -3, -3 minus 2 is -5. So my x value is -5. And again, you could check it into both equations, we get the same 2 points. Okay, so in terms of y, our area, we're working sideways. So we're looking at the function that's always on the right side is the sideways parabola. So we're going to be taking the parabola and subtracting off the line, right? Because the line is always on the left. Right, so it's the curve on the right minus the curve on the left. We're looking at our y bounds, so that's from -3 up to 2. That's a 2 dy. And we can evaluate this, and we should get a value of 125 over 6. Okay, so that's working in terms of y. The other one was to work in terms of x. So we need to rewrite all of our equations as y as a function of x. Now, of course, this sideways parabola, as we talked about in class, is not a function, so it's going to end up being two curves. So when I solve x equals 4 minus y squared for y, so I can subtract 4 over to the other side, but then I have a negative, so let's multiply everything by a negative. So we have 4 minus x equals y squared, and then y is going to be plus or minus the square root of 4 minus x. For my other equation, I have x equals y minus 2. Solving for y, we just add 2 to both sides, so x plus 2 equals y. So here's one equation, here are 2 more equations. So let's look at this. This one is obviously still the line. This is two curves. We've got the top half of the parabola. So let's change the color here so we can see what's happening. This isn't, somehow this is not getting, that's not green. What's happening? Oh, that's the outline. Let's change. I don't know why this isn't working. Okay, so the top half of the parabola is the curve y equals the square root of 4 minus x. And then the bottom half, that's not going to come out good. Y is the negative square root of 4 minus x. Sorry, I don't know why my pens aren't changing colors. So we'll just go back to black. Okay, so how do we express this area? So what I have to notice is that when I'm looking from left to right, all the way over here, x equals -5, this whole area, I've got the line is on top, and then the bottom half of the parabola is on the bottom, all the way until I get to 0. right? For this whole region, I've got the line on top and the bottom half of the parabola on bottom. So when I set up this area, the first region is the line in terms of x, which is x plus 2, minus the bottom half of the parabola, which is negative the square root of 4 minus x. And those are the bounds from x equals negative 5 to x equals 0. And then notice I've only found the area of this region here, so now I have to go to the rest of this region. I've got the red part is the top half of the sideways parabola, right? That's the top curve minus the bottom half of the parabola. So I have the square root of 4 minus x minus the negative square root of 4 minus x. And those bounds are from x equals 0 to where we hit the x-axis, so that's 4. Right? I don't know why this is getting in the way there, but of course you'll notice here that this is the same thing as the square root of 4 minus x minus a negative, so that's plus 4 square root of 4 minus x. So these two together would give me 2 times the square root of 4 minus x. So if you take this integral's value plus this integral's value, you're going to get that same value of 125 over 6. So in this case, it was obviously much easier to work in terms of y, because we only had to do one function minus the other. And that's mostly because x is a function of y here, and y is not a function of x. So there you go. That's how we do that problem.